Welcome back to Simplified Chemistry. This is part 2 of the Simple Titration Calculation video series. In part 1, I covered how to calculate unknown concentration of an alkaline or a base in moles per decimeter cubed. In this video, I'm going to show you how you can calculate the unknown concentration of an alkaline or a base in grams per decimeter cubed if you're given concentration of another solution. I'm going to use this worked example to take you through step by step how to calculate the concentration of a solution in grams per decimeter cubed for an alkaline or an acid if you're given another solution which is got a known concentration. 25.0 centimeter cubed of a 0.200 moles per decimeter cubed sodium carbonate solution was titrated against a solution of hydrochloric acid of unknown concentration. 20.0 centimeter cubed of the acid was required. What was the concentration of the acid in grams per decimeter cubed? Step 1. Write a balanced chemical equation if you're not given one. Here I'm showing you a balanced chemical equation of this titration. 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid to give 2 moles of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide. Step 2. Write down the volume, the concentration, and the number of moles that are given for the acid and for the alkaline. I'll start with sodium carbonate. The volume of sodium carbonate is 25 centimeter cubed divided by 1000 to convert it into decimeter cubed, which gives us 0.025 decimeter cubed. The concentration is 0.200 moles per decimeter cubed. We don't know the number of moles. For hydrochloric acid, the volume is 0.020 decimeter cubed. We don't have the number of moles. We also do not have the concentration. Step 3. Calculate the number of moles of sodium carbonate. We start with sodium carbonate because we know the concentration of sodium carbonate, which is equal to 0.200 moles per decimeter cubed. We calculate the number of moles using this formula. The number of moles is equal to the concentration in moles per decimeter cubed times volume in decimeter cubed. Therefore, the number of moles of sodium carbonate is equal to 0.200 times 0.025, and this gives us 0.0050 moles. Step 4. Calculate the number of moles of hydrochloric acid. From the balanced chemical equation, 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid. Therefore, to get the number of moles of hydrochloric acid, multiply 0.0050 moles by 2, and this gives us 0.010 moles. Step 5. Calculate the concentration of HCl in moles per decimeter cubed. Concentration in moles per decimeter cubed is equal to number of moles divided by volume in decimeter cubed. Therefore, the concentration of HCl in moles per decimeter cubed is equal to 0.010 moles divided by 0.020 decimeter cubed, and this gives us the concentration value, which is equal to 0.500 moles per decimeter cubed. From the concentration value of 0.5 moles per decimeter cubed, we can infer that 0.5 moles of HCl are contained in a volume of 1 decimeter cubed. Now we need to convert 0.5 moles to grams. We can apply this formula: mass is equal to moles times molecular weight. The molecular weight of HCl is 36.5. Therefore, mass is equal to 0.5 times 36.5, and this gives us 18.25 grams, and therefore the concentration of HCl in grams per decimeter cubed is equal to 18.25.